Alright, in lesson 11, we're going to talk more about similar triangles. Okay, so our goal is to determine if two triangles are similar based on the information given. And in lesson 10, we did the angle criterion, where if two of the angles, or if two corresponding angles were congruent, then the triangles were similar. Okay. So now we're going to look at this triangle. Okay, it gives us an angle that's 30, or these two triangles, sorry. Two angles that are 39 degrees, a side that's 2 and a side that's 3. And based on that information, do you believe that triangle ABC is similar to triangle DEF? Okay. So think about this. What if we combined information about a dilation, okay, and information about similarity, okay? That is, can we translate triangle ABC so that the measure of A is equal to the measure of D? Can we move this onto here? We could, and it would look like this. Okay? These would line up right here. Angle A and angle D would line up with 39 degrees. A to E, the distance from A to E is 1, and the distance from A to B is 2. The distance from A to F is 3, and the distance from A to C is 6. Okay? Now, can we tell if they're similar? Okay? We still don't have enough information about the angles, but we can use what we know about a dilation and the fundamental theorem of similarity to find out if side EF is parallel to side BC. So if these two sides are parallel. Okay. If they are, then triangle ABC, the large one, is similar to triangle DEF because of the corresponding angles of parallel lines are equal. We don't have the information we need about corresponding angles, so let's examine the information we are provided. So we need to determine if the sides are in proportion. Okay, so is the length from A to E compared to the length from A to B equal to the length from A to F compared to the length from A to C? Okay, so let's plug this in. The length from A to E is 1. The length from A to B is 2. The length from A to F is 3. And the length from A to C is 6. Now, 3/6 can simplify to 1/2. So 1/2 equals 1/2. So this isn't a ratio. They are in proportion to each other. And our scale factor with a center, so we could do a dilation with center A with a scale factor of 1/2 on the large triangle and get DEF. Okay. And since the ratios of corresponding sides are equal, then by the fundamental theorem of similarity, we know that side EF is parallel to side BC, and the corresponding angles of the parallel lines are equal in measure. So because we can see that this is a dilation, okay, and that our ratio is, or our scale factor is 1/2, then we know that this is parallel to this because we can do a dilation. Okay, so this angle here and this angle here are corresponding angles, and they are congruent. And this angle here and this angle here are also corresponding angles, and they are congruent. So this shows us another way to determine if two triangles are similar. So if they have one pair of equal corresponding angles, this one, it's the same corresponding angle that's equal, okay, and the ratio of the corresponding sides is equal like this, so they have this same ratio, then the triangles are similar. So this right here, if you can prove that they have one angle that's the same, and that their side lengths, or two of the sides, have a similar ratio like this, then yes, they are similar. Okay, let's look at another example. Okay, so we have triangles ABC, which is the small one, and we have triangles A, B prime, C prime. And we want to know if they are similar. Okay, so when we look at this, okay, in the last example, we had to have one angle that was the same measurement, and then we had to have corresponding sides that had a ratio. So we had to have a ratio by scale factor. So let's look first for the angle. It doesn't provide information about this angle, or this angle, or this angle. So because we don't have information about two pairs of corresponding angles, we're now going to examine, so no info about two corresponding angles. Now we're going to look at the sides. So I'm going to say the distance from A to B prime compared to the distance from A to B. And we want to see if it's equal to the distance from A to C prime compared to the distance from A to C. So 8 over 4.9, does that equal 7.1 over 2.7? And I can't easily simplify that, so I would use a calculator and see if when I divided that out, if it was the same. So here we go. 8 divided by 4.9 is 1.6. Does that equal 2.6? They are not equal. So because they are not equal, okay, then the triangles are not similar. So because we don't have two corresponding angles that are the same, and because our scale factor or ratio is not the same, triangle ABC is not similar to triangle AB prime C prime. Okay. Example 3. Given the information that these two triangles are similar, so it's going to tell you they are similar, can you determine the length of segment AB? Okay, so we know that AC is 5, AC prime is 15, AB is 2, and AB prime. So what we're trying to figure out is the distance here. Okay. So these triangles are similar. So What we're going to do is that because it tells us they're similar, we know that this angle is the same. We know that this angle and this angle, not this angle, and this angle are the same. And we know that this 1, 2, 3 is similar to this one, 1, 2, 3. They have the same angle measures. These two have the same angle measures, and this one has the same angle measure. So now we have to find the ratio of the corresponding sides so that we can determine the length of AB. So I know the distance from A prime to C prime, A to C prime, would be corresponding to the distance from A to C. And I get this from the definition of a dilation, okay? And let me just kind of show you this. Okay, the distance from A to C prime equals the scale factor times the distance from A to C. I want to solve for my scale factor. These two things right here are being multiplied. So to solve for the scale factor, I want to get rid of the distance from A to C. So what I do is I divide by the distance from A to C. So my scale factor is the distance from A to C prime over the distance from A to C. So that's why I use this ratio. You always put the image, the one with the prime, on top, and you put the original on the bottom. Okay, so I want to see what my scale factor is, or what the ratio is. Okay, so the distance from A to C, I'm going to move this over here. The distance from A to C prime over the distance from A to C should equal the distance from A to B prime over the distance from A to B. Okay, so A to C is our 15. A to C is 5. I don't know the distance from A to B. That's what we're solving for. And the A to B prime. And the distance from A to B is 2. Okay? So, because we know that for equivalent fractions, we multiply the numerator of the fraction by the denominator of the other fraction, the products are equal, so we can use that fact to find the length of side AB. Okay, so what we're going to do is that's just cross multiplication. Okay, so to solve this, it's just cross multiplication. So I'm going to multiply this by this, and it should equal this by this. So 5 times x equals 15 times 2. So 5x equals 30. Divide both sides by 5. X equals 6. So the question was, what is the length of AB? So the length from A to B prime is 6, whatever it was. Okay? Here's another one. Now we're going to throw in a couple different things here. So we know that xy is parallel to x prime, y prime. That's given. So this is parallel to this. Okay? Can we use the information to determine if triangle OXY, which is the small gray one, is similar to triangle OX prime, y prime? Okay? Since it tells us that these are parallel, okay, we know that we have similar triangles because each triangle shares this angle O up here. Okay, and the corresponding angles are congruent. So angle OXY, this one right here, is congruent to this one. Corresponding angles of parallel lines are congruent. and this angle here, OYX, is congruent to OY prime X prime. Okay? So, because of the angle criterion, we know that they are similar. Two angles in the triangles are the same, so they are similar. Now that we know they're similar, we can determine the length of OX prime. Or can we determine the length of OX prime? So, because of the converse of the fundamental theorem of similarity, since we're given parallel lines and the length of the corresponding sides xy and xy prime, we can write a ratio that represents the scale factor by using the fact that cross products must be equal to determine the length of side OX prime. So, what that means is we're looking for the scale factor, just like we did in the last one, to find the missing side. So, let's change colors. The distance from OX prime equals the distance from O to X, or compared to the distance from O to X, equals the distance from OY prime compared to the distance from OY. So let's plug in here. The distance from O to X is what we're looking for, so I'm just going to call that X. O to X prime, sorry. And O to X, it tells us is 4. O to Y prime, oh, we don't want to use that one. We want to use the ones that we're given, so this one and this one right here. Okay. So the distance from X prime, Y prime over the distance from X, Y. We have to use one that has them both listed. So 6.25, the distance from X to Y, over the distance from X to Y is 5. So again, we're going to use cross products, cross multiplication. So I'm going to multiply here. So 5x equals 4 times 6.25. So 5x equals 4 times 6.25, 25. So this is multiplication, so we divide both sides by 5. X equals 5. So, side OX prime equals 5. Now, using this information, we want to find the distance from O to Y prime. So we're going to do this again. I'll do it right here. So again, we're going to use the two that we have. So the distance from X prime, Y prime over the distance from XY equals the distance from OY prime over the distance from OY. Okay, and remember when we do this, the new one, the one that has been moved, goes on top. So the image goes on top because of when you do work out the definition of dilation, you're dividing the new one by the original. Okay, so the distance from X to Y prime is 6.25 over the distance from X to Y is 5. We're looking for the distance from O to Y, so I'll call that Z. And the distance from O to Y is 6. So again, cross products, we're going to cross multiply. So 5 times Z, 5Z equals 6.25 times 6. So 5z equals 37.5. Okay, and we divide both sides by 5. Z equals 7.5. So side OY prime equals 7.5. Whew. So yes, we can use the information to determine that they are parallel or similar, and then we can find the sides because we can find the ratio between them. Example 5. Given the information provided, can you determine if triangle OPQ is similar to OP prime Q prime? So this gives us two sides of the dilated triangle. It doesn't tell us anything about angles, and it only gives us one side down here. Now, because we only have 3 sides of one of the triangles, and we don't know anything about the larger triangle, we cannot determine if they're similar or not. We would need more information. Okay, we would need information about 2 pairs of corresponding angles, and that's not provided. Okay, so for this problem, this question right here, we could not determine if OPQ is similar to OP prime Q prime. There's not enough information given. Okay, so now we're going to jump into your exercises, and we're going to work through both of the examples. I think there's 2. The 3 examples real quick, and then get you on your way. So in the diagram below, you have triangle ABC and triangle A prime, B prime, C prime. Use the information to answer parts A through D. Based on the information given, is triangle ABC similar to triangle A, B prime, C prime? So we have the length from A to B prime. We have the length from B to C. We have the length from C to B. So we have these two. We don't have any more information here or here. We would need at least some more information somewhere, or information about angles. So there's not enough information to determine if the triangle is similar. Okay. Because we would need information about a pair of corresponding angles, or more information about the side lengths of the triangle. B. Assume the line containing BC is parallel to the line containing B prime, C prime. With this information, can you say that triangle ABC is similar to triangle A prime, B prime, C prime. Because if these two lines are parallel, okay, we know that they are similar because they share this angle right here, okay? And if these lines are parallel, then this angle and this angle are the same, and this angle and this angle